Hey guys, in this video I'm going to be talking about this worksheet on combination and permutation is actually just the first half, and then the second half is probability. So we're going to be doing both of these, see how long this video ends up being. I might do it in 2 videos. But that being said, let's go ahead and talk about permutation and combination. So combination is just a group of things, right? So if I have like 1, 2, 3, how many combinations of one? Say I have 3 and I want 2. So I have 1, 2, and 3. How many combinations of 2 of those numbers do I have? I have so the numbers that I have available to me are 1, 2, and 3. I can only use each of them once. Think of them as objects. Object 1, object 2, object 3. And I want how many combinations of each of those numbers? Well, I have 1 and 2. I have 1 and 3. I have 2 and 3. That's it. Those are all the combinations of those 3 numbers that I have. Because in combinations, because in combinations, the order doesn't matter. So if I'm looking for the permutations of those 3 numbers, the order does matter. So this was combinations. Permutations, the order matters. So I have 1 and 2, 2 and 1, 1 and 3, 3 and 1, 2 and 3, and 3 and 2. Because in permutations, the order matters. So it's like combinations, except for the order matters. So let's use that on some of these examples. So I'm going to be doing the evens on this worksheet. So let's look at how we can tell, looking at a situation, whether it's going to be a combination or a permutation, and then how we would find that. And I'm going to be teaching you guys some formulas for combinations and permutations. So let's look at this first one. A team of 12 lacrosse players needs to choose a captain and a co-captain. Now, I'm assuming that a captain and a co-captain are 2 different things, which means order is going to matter. I'm not just picking 2 people and they're going to be have the same role. I'm picking 2 people that are going to have different roles. So the order that I pick them matters. So for example, if I had, if I just had a group of 12 people and 6 of them were going to get to play that day, then order wouldn't matter. Those 6 people would get to play no matter which order I picked them in. But in this case, I'm picking 2 people. The first person I pick is going to be captain. Second person I pick is going to be co-captain. The order matters. So this is going to be permutation. So let's look at the formula for permutations. So the formula for permutation, I'm going to write it over here. That exclamation point doesn't want to look like an exclamation point, but anyway. So this is permutations in terms of n and r. That's what that means. N factorial. So n is the sample size. It's the number of things that I have to choose from. R is the subset, or the number of things that I'm choosing. So in this case, n would be 12 and r would be 2 because I'm choosing 2 people, captain and co-captain. So n is what I'm choosing from. R is the number that I'm choosing, or sample size and subset. And then this is n factorial over n minus r factorial. So let's look at how we would use that in this situation. So I have 12 players, so that's my n. So I have 12 factorial over 12 minus 2, because again, I'm picking 2 people. So r is 2 factorial. So I have 12 factorial over 10 factorial. Now we know, hopefully, that 12 factorial is 12 times 11 times 10 times 9 times 8 times 7 times 6 times 4 times 3 times 2 times 1. I don't want to have to do all of that. Luckily, there is a way we can simplify this. So I'm going to write this as 12 times 11 times 10 factorial. Do you agree that that makes sense? Over 10 factorial. So 10 factorial, right, is 10 times 9 times 8 and so on. So 12 factorial is 12 times 11 times 10 times 9 times 8 and so on. So I can rewrite it like this. So now I have 10 factorial and 10 factorial, and I can cancel those. So I'm just left with 12 times 11, which is 132. So this is a permutation, because it asked permutation or combination. So this is a permutation, and it's going to be 132. So there are 132 different permutations of captain and co-captain that I could pick for a lacrosse team with 12 players in it. That's a lot. All right, so let's jump down to number 6 here. I will do 4, but I want to do 6 first. I have my reasons. All right. Let's do this. Okay, so there are 30 applicants for 3 computer programmer positions. So all 3 of the people who are going to be picked are going to be computer programmers. They're going to have the same job. So the order that they're picked in doesn't matter. Therefore, this is a combination, not a permutation. I'm not writing out the whole word because when I'm writing on my screen with my finger, my handwriting is terrible. So I'm just not going to make you suffer through that. Anyway, so this is going to be a combination. So now we need the formula for combinations. This is going to be combination. N and R mean the exact same thing that they meant for permutation. The difference here is that we have this extra R factorial on the denominator, which is going to make this number smaller, which makes sense because, as I showed in the example earlier, you have fewer options if the order doesn't matter. So in the 1, 2, 3 example I had at the beginning, we had 3 combinations and 6 permutations. So makes sense that this should end up being a smaller number. So the only difference here is this R factorial in the combination formula. So let's go ahead and do this example. So N is going to be 30, our number of applicants, and R is going to be 3, the number of people that actually get the position. So how many combinations of 3 people can we get out of a group of 30 people? So we're going to do N is 30, so we have 30 factorial over R factorial, so 3 factorial, 30 minus 3 factorial. So that's 30 factorial over 3 factorial, 27 factorial. Notice that what's on the bottom here will always add to what's on the top. So 3 plus 27 is 30, which makes sense because this number is the same as the number we're subtracting. So if you've done it correctly, these will always add up to this. Just sort of a note, self-check, way to self-check yourself. That was redundant. Anyway, so I'm going to do the trick again with expanding the top until I have a factorial that matches the bottom. So I have 30 times 29 times 28 times 27 factorial. I'm running out of space. And then I have 3 factorial times 27 factorial. So the 27 factorials will cancel, and I have 30 times 29 times 28 divided by 3 factorial. So that's 30 times 29 times 28 divided by 3 times 2, which is 6. technically 3 times 2 times 1, but multiplying by 1 doesn't do anything. So I have 30 times 29, I'm putting it in a calculator, times 28 divided by 6, which is 4,060. 4,060. So these are your permutation and combination formulas. So these are the ones you're going to be doing for these and the Khan Academy assignments. Now let's do number 4. Number 4, Brenda and James are planning trips to 3 countries this year. There are 15 countries in the world. There are 15 countries they would like to visit. One trip would be 1 week long, another 2 days, and the other 3 weeks. So there are 15 countries they want to go to. They're only going to go to 3. If that was all the information we have, that would be a combination. But since the lengths of the trips are going to be different, the order matters because there are different lengths of trips. It's not going to be just we're going to 3 different places. We're going to 3 different places. One will be 1 week long, one will be 2 days, and one will be 2 weeks. So the order matters here. So this is permutations again. So permutations, so we're going to be using that permutations formula. So we have 15 factorial over 15 minus 3. Again, 15 countries, but they're only going to go to 3 of them. And we don't have this term because it's permutations, not combinations. So this is 15 factorial over 12 factorial, which is 15 times 14 times 13 times 12 factorial over 12 factorial, which is just 15 times 14 times 13. So sticking that in a calculator, we get 2,730 permutations. So there's 2,730 different ways that they could plan out this vacation. All right, so that's permutations and combinations. Hopefully that makes sense. And let me know if you have any questions. If you want to pause this video and do something else, or like do the worksheet or the Khan Academy, this would be a good time. I'm going to just go straight on into probability now. And I'm not going to make it a separate video. You can just pause this video and then come back to it when you're ready to do probability. I'm just going to keep going. So that being said, let's keep going. So probability. Okay. It's glitching up here, but it doesn't really matter. All right. A car dealership has 16 cars in the lot. Unfortunately, the keys to the car have been mixed up. The manager randomly grabs a key and tries to start a car. A salesman also randomly picks a different key and tries to start another car. What is the probability that both cars start? So let's start with what is the probability that one of these cars starts. So the probability that the first one starts, so there's 16 cars with 16 keys, right? So the probability that the manager randomly picked a key that started the car would be 1 in 16, right? There's a 1 in 16 probability that when he picked the random key, it started a random car, right? Because there are 16 cars. So I picked up a key, went into a car, and they matched. It's a 1 in 16 chance that that's going to happen. The other guy grabs the key. Well, now there are only 15 keys. So he has a 1 in 15 chance. Assuming that this one worked, there are now 15 cars that he can also try. So we're assuming that this one worked, because if this one didn't work, then this scenario is not going to happen anyway, right? So assuming this one worked, the salesman now has a 1 in 15 chance that the next car is going to start, because they've already eliminated one, right? So one car has been taken care of, so the next guy has a 1 in 15 chance. And if they kept doing this, it would go on like that, right? The next guy would have a 1 in 14 chance, and then the next guy would have a 1 in 13 chance. But so the probability that both of these things happen, we get that by multiplying them together. So the 1 in 16 chance times the 1 in 15 chance will give us the probability that they both got it right on the first try. So we're going to multiply these two together. So that's 1 in 240 chance. So that's not very likely. So 1 divided by 240 is 0.004166666, repeating, which is 0.417%. That's approximate. Obviously, like I said, it repeats, but this is a 0.417%, right? Okay. So that's the trick with this, is you get rid of 1, so this denominator has to go down, right, each time. Yeah. All right, let's do the next one. So a test consists of 12 true or false questions. A student who forgot to study guesses randomly on every question. What is the probability that the student answers exactly 5 questions correctly? The first thing we need to ask ourselves is, what is the number of possible outcomes? So I have 12. I have 12 true or false questions. So I have 12 questions, and each question has 2 possibilities. It could be true, could be false. So the total number of possible outcomes of what this student could do is going to be 2 to the power of 12. 2 to the power of 12. So that's 2 possible outcomes for 12 questions. So, for example, one of these many possibilities would be that he puts false on all of them. Okay, so one would be he puts false on all of them. One would be he puts false on all of them except for the second one where he puts true. Or false on all of them except for the first one where he puts true. And you can keep going on and on and on like this for exactly 4,096 possibilities. So there are 4,096 ways that the student could fill out this test. It's a lot of ways. But that is the number of ways that he could fill out the test. Then we need to think about, okay, what are the possible, of those 4,096 ways that he could fill out this test, what are the possible ways in which he would have 5 correct answers? So what are the ways he could have 5 correct answers? Well, we need the number of combinations that would give us 5 correct answers. So combinations, not permutations, because it doesn't matter what order the answers are in, just that they're correct, right? So I need how many combinations are there? How many ways are there to get 5 correct answers out of 12 problems? So I need the combinations from 12 questions that would give us 5 correct answers. So if we remember our formula from earlier in the video, that would be 12 factorial over 5 factorial times 12 minus 5 factorial. So that's 7 factorial. So 12 minus 5 is 7. Again, these two should add up to this one. So that's good. And then simplifying that down, you get 12 times 11 times 10 times 9 times 8 over 5 factorial, which is 5 times 4 times 3 times 2 times 1, but who cares? And you could continue to simplify that, or you could just put this in your calculator, up to you. And what you end up with is 792. So there's 77 out of the 4,096 ways that he could fill out this test. There are 792 ways where 5 of the questions are correct. So the probability then would be 792 out of 4,096, which is 0.19336-ish, or 19.34%. Sorry that it's a little squished. But this would be our answer, 19.34% chance that he would get 5 questions answered correctly on this test. And if you go through this process and do it again, you with higher and higher numbers of correct answers, you'll see that the more correct answers you want, the lower the probability of getting exactly that many correct answers is. So that's just an interesting thing. You can see mathematically how if you're just guessing, the more you want to get right, the lower the probability that you're going to do that by guessing, which you guys all know intuitively anyway, but interesting to see it mathematically. All right, so that is this this video, and I just realized that these two questions are the same, so I'm going to change this one, and then because this is the same question. No, it's not. Never mind, it's not the same question. It's not the same question. Never mind. Not going to change it. It's not the same question. Yeah. So hopefully this helps, and I will see you guys in the next video. Let me know if you have any questions.